Hi everyone, hope you're having a great day today. We're going to go over chapter 8.3, which is basically a summary of everything that we've covered up to this point about conic sections and how to graph them and how to identify the equations, whether it is a circle, an ellipse, parabola, or hyperbola. Let's look at the characteristics of each one of them in standard form. So in standard form, you're going to have all of the variables and constants on one side and set it equals to 0. Now, whenever we are dealing with standard form, you can probably just look at it and be able to determine whether you have one out of the four using these characteristics. So for a parabola, remember that you either have y equals x squared or xy squared. So only one of them is squared. So that means that a or c have to be 0, but not both of them. So here we have a or c equals 0, so therefore we have y equals x squared, for example. So for goal a have to equal to c, of course it cannot equal to 0, and most of the values here is a and c cannot be 0. So if a and c is not equal to 0 and they are equal, how you know that you have a circle. For an ellipse, you have a not equal to c, and a times c is greater than 0. So remember that for an ellipse, okay, it's going to be very similar to a circle, okay, but the denominator, or basically the denominator of the x squared and y squared, have to be different from each other, and that's where this comes in. So you can see here, our a and our b values have to be, okay. For a hyperbola, AC have to be less than 0, which means that either A is positive and C is negative, or C is positive and A is negative. So A times C less than 0 means that either one of them have to be negative, they both cannot be negative at the same time. Okay, so I'll leave this up here and we'll go over some examples here. So we have x squared equals 25 plus 5y squared. Notice that this is not in standard form, because it is not, all the variables and constants is not set equal to 0. So we have to move this to the other side. And when we do that, you notice that we have the following. You have a positive a value, but a negative c value. So that means we're going to have a hyperbola. And that's it. That's all you need. Here, you're looking at the x squared and the y squared. Notice that the a and the same. So if they are the same, we're going to have a circle. And here we have a and c are different, so we're going to have an ellipse. You have only x squared here. There's no y squared. So you have x squared or y squared. You're going to have a parabola. So this is parabola. This is ellipse. This is circle, and this is hyperbola. Okay, so here you have y squared. Here you have x squared, but this negative, so we have another hyperbola here. Okay, see here, our first one is a hyperbola. And of course, you can determine what is the value of a and b. Then you can draw your rectangle. And we did all this last time. So what I want to, so all these shapes here we've practiced already. So what I want to focus on is finding out what is the eccentricity of the conic sections. Okay, so a conic is a set of all points in a plane such that the ratio of the distance from P to a fixed point of the distance from P to a fixed line constant. So that constant ratio is called the eccentricity of the conic, and that's E. So the E here, you see here, is the ratio of the distance between P to F, so from here to here, over P to D, okay? And this fixed point for this parabola here is the directrix. Now we're going to have different values, different shape. So for ellipse and hyperbola, we have eccentricity where C is the distance from the center to a focus, okay? So for ellipse, you notice that a squared is greater than b squared, And so C is equal to the square root of A squared minus B squared. So we can do the direct substitution here in order to solve for E, because E is basically the ratio of C divided by A. So let's look at what is the ratio of C over A give us. So here we have our ellipse. Here's our focus. And this value here is B. The value from here is C. The value from here to the vertex is A. So C divided by A. So you can see here my C value is smaller than A, right? Because my C value is only from the center to the foci. So you can definitely see here that E is going to be between 0 and 1. Now, as that eccentricity moved closer and closer. So basically what happened when I increase the value of C. So as C approaches A, or as C gets larger and larger and larger, as it is A, what do we have? So here, let's have a better ellipse here. Now, for this one, the C value is very close. So the C value is right here, whereas the A is from here to here. So as C approaches A, getting closer and closer, you get a circle. Okay? So when C equals to A, what you're going to get is a circle. So note, this is what they're noting here, that ellipses with eccentricity close to 0 have a circular shape because B approaches A as C approaches 0. I think I said that backward, as B approaches A, not as C approaches A. All right, so find the eccentricity of this ellipse. So here, E is equal to C over A. So we already have A here. Remember, A is always the larger one. B is a smaller one. So this, 3, 4. So to find C, take square root of A squared minus B squared. So we get square root of 7. So C divided by A, square root of 7 over 4, which is about 0.6. Okay. Okay. So let's look at what this one will give us. Now we have to divide by 50 to get this equal to 1. Okay. So we have x squared over 10 plus y squared over 5 is equals to 1. Now remember, these values are square, so we have to take square root of 10. And that becomes our A value, and that becomes our B value. So once you have your A and your B value, you can find out what your C value is equal to. So 10 minus 5, or A squared minus B squared, square root of that equals square root of 5. So my E is equals to square root of 5 over square root of 10, or about 0.71. So let's look at the eccentricity of each one. So let's see what happens. So as E gets smaller, so as E gets closer to 0, it's going to get closer and closer to a circle. And as E gets larger, it's going to flatten out. So as E gets closer and closer to 1, the ellipse is going to get skinnier, skinnier, or flatten out like this. Okay. So the main goal of this is as E approaches 0, the ellipse will become circle. So as E gets closer to 1, the ellipse is more flattened. Okay. All right. So for hyperbolas, you can see here as E get larger, this is you can think of it as flattened, but it's more, it opens wider. Okay. So as e get closer to 1, so this is for a hyperbola. This is for a circle. So as e approaches 1, the hyperbola flattens or gets nearer. So if you were to draw a box around here to help us draw our asymptotes, so this one gets flattened more, and here it just opens wider. Okay, so this one, it closes, getting smaller and smaller, and this one, it just widens up. So this one opened wider than this one. All right, let's look at the for hyperbola. Again, we have to follow the same formula. E is equals to c over a. So once what you determine what is c and a is, just plug in the formula. So here, the a value is always underneath the positive square. So if this was y square over here, it's positive, that would be your a value. So a here is 3. Then you follow the formula, a squared plus b squared is equal to c squared. So c is equals to 9 plus 4 square root. And that's where we got square root of 13. Plug into the formula, we have about 1.2. So this hyperbola is going to be very narrow. So it's going to look more like this. Okay. Okay, so now since we know the relationship between eccentricity and C and A, if they give us eccentricity, we can probably find out either C or A, depends on what's given. So this is similar to finding an equation of the conic sections where you are given pieces of information. So here they find the equation for each conic with center at the origin. So that means that we know our HK is 0, 0. And here, remember, E again is going to equal to what? C over A. All right, so for the focus is at 3, 0, and E is equals to 2. Now, since E2, we know that this is a hyperbola. If you look up here, okay, if E is between 0 and 1, we're going to have an ellipse, but if E is greater than 1, we have hyperbola. This is always true. Okay, so let's draw it. So this will help us. Let me copy in the graph. Okay, we have 3, 0, and our eccentricity is 2. And since we know that the center is at the origin, we also know that the other foci is over here. Now, since we know that E is equals to C over A, now this distance from the center to here, that is our A value. And our C value, we can find out from this. Okay, so A here is equal to 3, E is equal to 2, so let's plug it in. 2 is equals to C divided by 3. So that means it's equal to 6. And negative 6. And from there, we can find out our A value. So A squared plus B squared equals C squared. So from there, we can find out what our value is equal to. So So let's see. Oops. Did I miss something? Oh, I'm sorry. I messed up something. I was given C, not A. Wait, hold on. Am I doing B? Oh, shoot, I'm doing A. Oops. Focus is at 30. Oh, they're giving focus, not vertex. Sorry, I was reading as vertex. I mix up these two. Okay, so let's redraw that. Okay, focus is at 30, and eccentricity is at there. Okay, so center is here. So let's label that as F. So not mistaken here. So that value there is C. All right, so now we can plug it in. So we have 2 here, 3 here, and A. So A is the value from the center to the vertex. So that's what we're trying to find. So A is equals to 3/2. Okay. So we got our A value. So A squared plus B squared equals C squared. So now we can find out our B value. So what are they asking us to find an equation? Okay, so we need to find out B value. Okay, so C squared is 9, A squared is 9/4. Okay, so I have 3 squared 3 over 2 as my B value, but I should have just leave it as 27/4 because we're going to use that to write our equation. So we have, let's see, this one this way, so the x should be square. So I have x squared divided by A, which is 3/2 squared, which is 9/4, minus y squared over B squared, and this is my B here. So if I square that, I have 27/4 equals 1. Okay. So the only thing that's different from what you've been doing is that this time they actually give us the eccentricity is equals to C over A. And just like they give you either A, B, or C value, you can find out the values of the other one. Okay, so let's do the second one, the vertex here. So again, let's draw this. So they're giving us vertex at 0, -8. E is 1/2. Okay, so 0, -8 is down here. And C is between 0 and 1, so we know that this is an ellipse. And since the vertex is on the y-axis, that means that the other one will also be up here. Okay. So if this is the vertex, this is my A value. And ellipse here is 1/2 equals C over A. And my A is 8. So that means C is equals to 4. So from there, we can determine what our B value is. So remember, A is our largest one here. It's equal to B squared plus C squared. And since I'm solving for B, A squared minus C squared is B squared. And my A value here is 8, so 8 squared is 64, minus 16 is the root of that. It'll give me my B. Actually, let's just keep it square, because we need this. So B squared is 48. This is an ellipse with the center at the origin. So we have x squared over, so the larger value, which is 64, go over, sorry, this is along the y-axis. So that should be 48 plus y squared over 64 equals 1. Okay, and that's what we got here. Okay. Solving this system. We can skip that. Oh, and you will not be using any of these here. Okay. Wow, today's a short day. Okay, so this last section, the main idea here is to deal with eccentricity and be able to recognize which what is his standard form is, which graph you're going to get by determining by looking at the A and the C values. Yeah, and I think that's it. Might have any questions, or you want to go over any homework?
I have the question in slide number 19.
Okay, your homework section.
No, in the PowerPoint number,
Oh, the
slide
PowerPoint.
number.
Right. Okay. Yeah, this one.
Yeah, because why A is equal A, why is not
Okay.
negative A?
Okay, so you're asking why A is equals to 8?
Yeah, why is not negative A? Because
Oh, okay. Great question. Okay, so let's try to understand something. Okay. So A that I use. So remember that we have a relationship. A squared is equals to B squared plus C squared. Okay. Now, anytime that we're dealing with A, B, or C, they're always going to be a positive value. Okay. A, B, and C are always positive because it measures the distance from center. So anytime that we're dealing with distance, we only deal with positive value because negative means we are in opposite direction. And also because A is measured from here to here. Now that's the distance, right? Now, if you want to find out A, remember that in our standard form right here, our A value is the square root of this number. So when you take a square root, you can't have a negative number, right? So A value is always positive. Same thing with B and C. Does that make sense?
yes.
Okay, great question though. So even if I give you another point, for example, if I give you an ellipse with the foci being here, so you would measure the distance from here to here, not -4. This would be +4. Or if the center was somewhere else, let's say the center is over here. That's where the center is. And the location of one of the foci is right here. Okay, then by default, the other foci would be in the opposite direction. So this is 5. So the other foci would be here. This is also 5. So both of these distances here are +5. We don't say this is -5. We don't say this is +5. It is just +5 for the distance from the center to the foci.
Okay.
Okay. Any other questions?
No.
Okay, great. All right. So see, I think this is our last section for chapter 7, I believe. And then I'm sorry, 8. I might say the other one. So let's see. Yeah, I believe so. That's chapter 8. Then we need to start on 12 next time. Okay. Chapter 12 is super easy, so I think that will go even quicker than this. So the hard part will probably be chapter 8. Okay. All right. I'll see you Thursday. Have a great day.
Thank you.
Bye.